talk a little bit about the navigation of the Neuse. Now, when we talk of navigation of the Neuse, it's not like the open waters where you had nothing to look at to mark your way except for maybe the stars or maybe something way off in the distance that would give you a reference point. If you're on the open water, something like a sextant would be a very useful tool. You would be able to triangulate using this through sighting at a fixed object and in facing something else. Now, you're doing this as a horizontal. You're looking at something on the shore in two different locations. If you're doing the stars, you turn it vertical because you want to pick different stars. So this would be used in the open waters, but not on the Neuse River. Another useful tool is the compass. The compass was used on every ship that was made, and it goes back many, many years. It's a magnetic compass, and it always points north. So if you're standing here, and you hold this just like this, north is this way. If you turn like this, and you're still going north, but the needle did not change, but your hand position did. So anytime that you're steering by compass, you have to steer towards the number that you choose, not necessarily north. So if you want to go east, you would go this way. Whereas if you wanted to go west, this way. But it's still going to point north. Your compass is always going to point north. Now, modern day compasses have basically navigation interlays. And that basically converts the layout of the compass in the direction you want to go in. So if you want to go east, it will point east. But it has been calibrated so that when you read it, it's going to read the direction in which you're going. Now, a compass like this is affected by two different fields of energy. One is magnetic. Anything that you put close to it that's a magnetic field, like an iron, it will distort the reading of the compass because it's going to turn towards that that metal object. The other thing is the actual rotation of the Earth, and that is called deviation, or variance. The variance is where, because the Earth is turning, there is a constant tilt, one way or the other, depending on where you are, of the Earth. So as that is taking place, it's affecting the actual true north reading. So you have to account for that in your navigation. Now, the Neuse is a long river. The Neuse starts at the confluence of the Eno and Flat Rivers just north of Durham at Stagville. And it flows 275 miles to the coast. It's only about 140 miles distance-wise, but it's 275 miles surface. The most navigable point ends at about Goldsboro. From there it gets too rocky and too narrow to really navigate. I have a picture here of what the Neuse looks like near Kinston. So you can see how it twists and turns. And navigating on the Neuse would be very difficult at times based on the time of day, because you would need something to show you where you needed to go. In a river like this, you have shallows and you have channels, and you have to know where the channels are. Other things that would come into play are fallen trees. Have a storm, trees fall in the water, they hinder navigation. Back in this time, a landowner that had waterfront property on a river was responsible for keeping his section of the river clean. So if a tree fell in the water on his property, it was his responsibility to get that tree out of the water to keep it navigable. So This could have been a problem during the war because the trees would have fallen during storms and nobody was around to take up the trees. So that presented a problem. And the way that you could tell where the trees were was by looking through your binoculars, because these were your friend. They told you where to look and to see what was coming up around the bend, or as close as you could to the bend. So the thing that made the difference in navigating on the Neuse was local knowledge. You needed a pilot that knew the river, knew what was ahead, and knew what to expect based on the currents, the water level, and everything else. Now, when we talk about water level, the controlling depth of the Neuse at any point is somewhere between 4 and 6 feet. When you have what they call a fresh, which would be a lot of rainwater coming into the river would rise. If you had storms like a hurricane, we've seen what the hurricanes can do to the river. It can get extremely deep. The water flow, the current in the river exceeds the normal slow rate of about 1 mile or 2 miles an hour when you have a lot of fresh water in there, because it's running faster to get out to go downstream. So that does create quite a bit more speed. So when they say the Neuse was doing 6 to 8 knots, that was really fast for a boat. And you would add the 1 or 2 knots from the current, and you would basically be going about 10 knots. The way that they determined how deep the water was with the lead line. And this was basically a piece of lead that had a rope tied to it that was dropped overboard to determine just how deep the water was, but just how fast it would drop down. Yeah, and this is a typical lead line. Lead object, and then a rope on it. And it would be marked at different levels, either by tying leather in it or some different color or fabric or something to show what the depths were. And this was a very handy tool, because if you didn't have enough water and you drew 6 or 8 feet of water, you had to be careful where you were going. So navigating the Neuse was not an easy task, but it was something that had to be done to get the boat downstream. And this is one of the reasons that the Neuse never saw a lot of battle, because on its first trip towards Newbern, it was caught up on a sandbar just outside of Kinston here, and it stayed on aground for almost a month because the water was falling, no fresh water, no rain, and it took that long for the river to come back up so they could get the boat free. So it was very important that their timing be perfect for the season of the year and the depth of water before they could move the boat. And that, like I say, is one of the reasons that it got hung up, is because it was during a time when the water was low. Okay, that's it.